Okay, today we are going to start lesson 5 on simplifying expressions. This starts on page 387 of your textbook. But before we can do that, we need to identify the parts of an expression. And I've already talked about this a little bit in class about what are the different parts of an algebraic expression. It says here on page 388, when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. Recall that the numerical factor of a term that contains a variable is called the coefficient of the variable. So, sorry, I only meant to box in coefficient. That's the definition of coefficient, the numerical factor of an algebraic expression that contains a variable. So the number that's being multiplied by the variable is what a coefficient is. Like terms contain the same variables to the same powers. For example, 3x squared and negative 7x squared are like terms. Even though the 3 and the negative 7 appear to be different, the x to the second power in both of those terms are what make them like terms. So x to the second power makes them like terms. So are 8xy squared and 12xy squared, because the xy to the second power is the same in both of those terms. But take a look at 10x squared z and 22xz squared. They are not like terms. Even though they at first look like they have the same variables and stuff, x squared is not x. And z to the first power is not the same as z to the second power. These are not like terms because the powers are on the different variables. So they are not like terms. So a term without a variable is called a constant. I've also talked about this in class. A constant is just a number with a plus or a minus sign in front of it. It is a constant because it has no variable with it. But constant terms, if you have multiple of them, they are like terms as well. So if I have a 12 and I have a negative 7, those would be like terms, even though one's positive and one's negative, because neither one of them has a variable. So let's take a look at this little chart that they have here. I do want you to copy just this negative 4x plus 12 plus x down. And we are going to label it, but we're going to label it a little bit differently, I think, just so you don't have to write as much, but it will still make sense. So first, we're going to put there are 3 terms in here, but you can use the number 3. And then I want you to put a small arrow up here, and I want you to write coefficient. You might have to write that further away. I before E except after C. I think I just spelled that wrong. Nope, that's correct. There's always words that break the rule. So negative 4 is a coefficient, but then I want you to write here another arrow. And I want you to write coefficient is 1. And I want you to put that in a box. That is very important. When a variable is by itself, it has a coefficient of 1. 12 is a constant because it has no variable. And these two terms are like terms. And the reason they're like terms is because they both have the variable x to the first power. So make sure you have this copied down. So let's take a look at the first example on page 388. It says, identify the terms, like terms, coefficients, and constants in this expression 6n minus 7n minus 4 plus n. Okay, this is how I would like for you to do these problems where it asks you to identify the things. I would like for you to first write them out. 6n minus 7n. Make sure you give yourself plenty of room. Don't squish things up. You're not going to be able to do what I want you to do if everything is squished. So, first thing I would like you to do is to box all like terms together that have a variable that is the same. So 6n and negative 7n are like terms because they both have n to the first power, and positive n is also a like term, so box it in because it also has n to the first power. Then I would like you to circle the constant. If you had more than two types of terms in your problem, we could add other shapes like a triangle or a diamond. Sometimes works really well as well. But because we only have two types of terms here, one with the letter variable n to the first power and a constant with no variable, this is sufficient. What this does is it identifies the terms and it identifies which terms are alike. So we don't have to write anything else out for terms and like terms. We're good there. Then I would like you to write the word co-e. We're going to write out the coefficients here. Coefficients are the numbers being multiplied by the variable. So you can see that 6 is being multiplied by n, comma, negative 7 is being multiplied by n. And then what is the third coefficient? Well, if you refer back to the diagram that we just did, I said any letter that stands by itself has a coefficient of 1. You have to list that 1 out for the coefficient that is right there. It is understood. Now that we've covered coefficients, the only thing left is constants. So you can just write CON to abbreviate constant, and we have one constant, and it is a negative 4. Make sure you include the negative sign because it is a negative number, not a positive number in this problem. So now you are ready to do A and B, but first go on to the remaining examples and you can do the letter problems after the video. The bottom of page 388, it says simplify algebraic expressions. An algebraic expression is in simplest form if it has no like terms and no parentheses. It can have neither one of these things. Today, we're mainly focused on having no like terms. But yesterday, when we were doing the distributive property, we were actually simplifying those expressions by getting rid of the parentheses. We were distributing what was outside to what was inside to get rid of the parentheses. And that's why it says here, use the distributive property to combine like terms, because you can get rid of parentheses that way. So take a look at example number 2. On page 389, it says 4y plus y. What we want to do is we want to take these two like terms, 4y and positive y, and because they are like terms, I'm going to box them just like I did on the previous problem. And I'm going to add together their coefficients because they're both positive. So 4 is the coefficient of 4y, and remember there's that understood 1 that is the coefficient of y. So together that would be 5y. So this is where people get in trouble here is because they forget that that has a 1 as a coefficient, 1y. 1 is the 2. 1 is the coefficient. Write 7x minus 2 minus 7x plus 6 in simplest form. So they give you one that's got a little more to it here. And again, give yourself space. Don't worry about how much paper you're using. Worry about getting this correct. 7x and negative 7x are like terms because they both have x to the first power. Negative 2 and positive 6 are both constants because they have no variable. So we're going to use our commutative property rule to say that we can rearrange this as 7x minus 7x and 6, positive 6, minus 2. And so we have things grouped together in an order that makes sense. 7x minus 7x would be 0. So these things, they just cancel each other out because they are opposites. So for the purpose of this example, please write opposites cancel out. And then 6 minus 2 equals 4. So my answer here is 4. In most of the problems that we do today, we're not going to get a number answer. The only time we're going to get a number answer is if the variable terms cancel each other out like this. So don't expect to get a number answer most of the time. Most of the time we're going to get an answer like we have in example number 2, where there will be an expression left over. So that brings you up to the second set of letter problems, C through E.